The idea for this talk is to help you get started or help you kind of improve a bit if you're trying to do specification by example, BDD, ATDD, or any of those similar techniques. Spec by example is a collaborative way of getting to requirements and tests that a lot of teams are starting to use these days. And there's an insane amount of stupid stuff online about it. So there's an insane amount of confusion. There's an insane amount of just kind of misunderstanding about that. So what I'd like to talk about today is how to really be successful with that. I've spent a lot of time interviewing teams in lots of different companies, from small web startups to very large investment banks, how they actually pull this off and what benefits they get out of that. And kind of that's what I'd like to talk about today. Some key conclusions, some key ideas that you can steal from all those teams to improve your testing process from that perspective. So spec by example, BDD, ATDD is a kind of not relatively new idea, actually. Although it's starting to become popular, or started to become popular only a few years ago. The first paper written on that was written in about 1995 by Ward Cunningham. So it's been around a while, people have been doing it, but like anything online, most of people that kind of try and do something stupidly then complain that it doesn't work, kind of that kind of stuff happens. So these days, one of the most popular things to complain about is Cucumber, the tool. And this is for most teams the first point of contact with techniques like this. And a lot of time you can kind of just see random complaints like this one done by David Heinmeier Hansen, who's one of the lead, I think he's the leading programmer for Ruby on Rails. And out of kind of, you know, everything that he heard, he's complaining that kind of people shouldn't really use Cucumber unless they are living a magic kingdom of non-programmers writing tests. And he's kind of complaining about Cucumber. The other guy that I found that's complaining about Cucumber says that, you know, customers, non-programmers never really write these things. And most of these complaints tend to be oriented against a tool like Cucumber, and they're oriented against somebody else not doing some work that we should be doing anyway, which is kind of a bit stupid. So kind of a ton of complaints like this online kind of are also related to how this thing breaks projects and is harmful and it's very expensive and things like that. And that's because lots of people have really burned their hands trying to do test automation in a way that is different from what they normally do. And then they create 1,000 tests that are brittle, they're very hard to maintain, that hurt a lot, and generally don't bring any benefits. And although Cucumber seems to be the poster child for complaining these days, there's nothing specific to Cucumber about this. Cucumber is just a relatively popular tool. Before Cucumber there was Fitness, before Fitness there was Fit. And kind of it's also very common to find how people complain about other tools, like this guy's complaining about Fitness and saying that he can do the same thing using NUnit. Why on earth would he use Fitness? And things like that. So the problem with all these things is kind of they're mostly complaining about a tool. And they're complaining about the tool from a perspective of not really understanding how to use that tool. And generally kind of the community around BDD, around spec by example, around ATDD has not done any kind of help here, because most of the descriptions of processes, how to use these tools, are completely broken. One of the thought leaders here who kind of pretty much started the whole BDD revolution, Dan North, tried to capture the description of kind of his ideal BDD process a few years ago, and this is what he came up with. So he came up with BDD is a second generation outside in blah 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 blah. So there's a scientifically proven fact that this is the only phrase in English that can be translated to Klingon without losing any meaning whatsoever. And that's not helping kind of with people not really understanding how to use this process or these tools. So we need to figure out how to communicate this thing a lot better, and that's a part of kind of why I'm here today. I'd like to inspire you to try something different. I'd like to inspire you to kind of try using these tools in a slightly different way, because that can bring incredible benefits to the team. And kind of, we have to stop trying to describe it like this. That's a big problem. So one of the best kind of ways of describing stuff that I found comes from a professor called Glenn Whitman. He's an economics professor at the California State University. And he had this famous conversation in a toilet once where somebody was asking him about what is economy. And he came up with a really long-winded explanation, to which kind of his colleague in the toilet said, no, just tell me two things about it that are the most important. And this started the two things revolution. That's amazing, where there's a whole website where people have collected two things about almost anything. One of my favorite descriptions is kind of two things about world domination that pretty much involves what everybody knows. There's another kind of really brilliant two things about on that website. It's kind of two things about web programming that kind of perfectly summarizes all my bad experience with web developers. And I think if we're going to kind of create any kind of sensible description that people can use, we can't do the Klingon thing. We need to do something that's nice and simple like this. So I think I have a description like that. And I'll kind of show it to you at the end. But kind of first of all, one of the biggest kind of challenges trying to describe a process is that our industry is incredibly obsessed with tools. We don't want to hear about processes because processes are difficult. That kind of means we have to change how we work. We like a tool. We like to install a tool. We like to know that now we're agile and everything is brilliant and everything's perfect and that's it. And with the whole kind of tooling thing, most people try and approach BDD or spec by example or ATDD from a perspective of test automation. That's kind of completely broken, but because most people do that, let's kind of try and look at that perspective as well. And the problem with automation, at least from my perspective with the people I work with, most people think that automating something makes it better. Actually doesn't, it only makes it faster. So sometimes faster is better, sometimes faster is not necessarily better. So I used to work for a company that didn't really have a good business model and they burnt a lot of cash. By burning it faster, they've not really made anything better. And kind of going to the two things thing, one of the most famous two things was actually formulated by Bill Gates. He formulated two things about business process automation. His first thing about business process automation was that if you apply automation to an efficient process, you will magnify efficiency. So if something's already good and you automate it, you make it even better. But the second thing about automation was that kind of, if you try and do the same thing on an inefficient process, it just becomes even worse. So that's the problem with a lot of people complaining about Cucumber, complaining about fitness, and complaining about a lot of other tools. It's kind of a garbage in, garbage out process. Cucumber or fitness don't make things better, they just make them faster. And if you try to put garbage in, well, you know, more garbage is going to come out more frequently. And that's the big problem. That's how people end up with 700 tests that are completely broken, difficult to maintain, and impossible to use. Now, the big question is, how do we move away from this? How do we get something that's not completely broken, that's not something that, you know, we need to fight with? And they said, that kind of approach to requirements and tests is not particularly new. It's been around for, you know, since 1995, and people have been doing lots of really good stuff, especially last decade, because iterations became shorter. And as kind of spec by example is a particularly good way of coming up with requirements and tests quickly, which means that if you only have 2 weeks to develop and release something, that's a pretty good way of kind of not spending 3 days out of those 2 weeks planning your testing and requirements and getting to something relatively quickly. So as the iterations became shorter, this thing became more and more important. That's why there's a lot of interest in it. But kind of somewhere in 2009, I was in a workshop in Paris where there were about 150 people in the room. All of them have tried this technique or something similar, and a lot of them have succeeded, a lot of them have failed, and we started trying to figure out what do the teams that have succeeded with this do differently. How do we identify common patterns for people that are really, really happy with this process? And what are the commonalities for teams that think they're wasting time, that they have 1,000 tests that are difficult to maintain, that are broken, and they think that Cucumber is the worst thing in the world? And that's where we started identifying some really, really interesting commonalities there. And as a result of that, there were a couple of Agile Alliance functional testing tools workshops where we continued comparing this process, and then I set out to interview people in lots of different companies to really figure out how they're doing this stuff. And out of that, we got some really, really interesting process patterns, commonalities for teams that got incredible success with this. I'll give you a couple of case studies later, but one of the teams I spoke with worked for a large industrial engineering company where the head of testing was fired because of problems with software in the field. And they hired a new guy who started transforming the process. About 1.5 years later, they stopped using a bug tracking tool. That's how much they cleaned up the system. And this is a big legacy, horrible bureaucracy organization. Another company I spoke with reduced their delivery cycle time from about 9 months to an average of 2 weeks by doing this process correctly. And those are the benefits we can get, rather than just complaining that Cucumber is too expensive and it's harmful and we can do it in a unit. So, one of the first things that comes out as a commonality for teams that got a lot of value out of this is that they tend to split their requirements into 2 forms. Teams that tend to waste a lot of time with this only have 1 form of requirements. They use the same form of requirements both for planning and for implementation work. And because user stories are the most popular stuff people use for requirements these days, translating that to user stories, that would mean that they're trying to use the same form of user stories, both for their planning 2 months ahead and for implementation, which then leads to 2 possible choices. One choice is that they only have one-liner user stories. As a blah, blah, I want blah, blah because of blah, blah. And then when that comes into implementation, it blows up immediately. And then people figure out it's a lot more complex than you thought, and then it needs to come back 5 times and things like that. Or alternatively, they try and do something that's very, very detailed so it doesn't blow up, but they do it 2 months ahead because they need it for planning. And that leads to what Forrester Research calls water scrum fall. Forrester Research published this paper on how companies adopt Agile, and they say that by far the most popular process is do all your requirements up front, very, very detailed. Then you children can go and play Scrum as much as you want, but then we'll wait for everything to come together and test it at the end. And in a case like that, organizations don't really benefit from short iterative cycles. So instead of doing one of those 2 options, the teams that get a lot of value out of this process actually use 2 forms of requirements. They use one form of requirement that's relatively vague but good enough for planning, that has some broad details about what we're going to do, and that's where user stories come in really, really nicely. But before those user stories actually come into an iteration, they tend to transform those user stories into a completely different form that's a lot more detailed. So generally those 2 things are done at different times. So scope level requirements, user stories tend to be produced, say, 1 or 2 months ahead, or even 3 months ahead, where they're good enough for planning, where people can organize work, hire people, fire people, buy equipment, schedule work around that, organize marketing activities. But because they can produce detailed requirements and tests relatively quickly, they don't need to do that much detail up front. This process liberates people to do relatively high-level scoping requirements. And user stories are not the only possible way of doing this stuff. I spoke to a team that does medical drug research software, and their regulator didn't want to see user stories, didn't want to know about user stories, they wanted use cases. So they applied the same approach by using use cases. They said, okay, we're going to use high-level use cases as scope, and then just before it comes to the implementation, will translate those things into something that's a lot more detailed, because that's when we need the details. So the other interesting kind of thing that clearly separates teams that have successful implementation of BDD, spec by example, ATDD from those that just waste time is who then translates this scope into a much more detailed specification. All of those people that complain online about non-programmers writing tests or non-programmers writing specifications or product owners never writing any of this stuff or things like that, they got it completely wrong. Because the successful teams, every single successful team that gets a lot of value out of this process organizes some kind of collaboration to translate from scope to detailed specification. So not a single team delegates this to one role. Either a product owner or a tester or a developer, can all of them collaborate. And there's some very good reasons for that. The first reason is if you have 20 people looking at something, it's going to be done a lot faster if you can facilitate it well. If you have 20 eyes looking at something, they'll spot a lot more gaps. They'll spot functional problems and inconsistencies a lot faster. If you involve testers in coming up with specifications, then they can build quality in rather than testing it later. They can kind of complain about the stuff that they would like to test so developers can build it right the first time around. If you get analysts to use developers and testers to help them analyze stuff, then analysts get a lot more time to work upstream and things like that. And kind of generally, there's an entire trend going towards whole team analysis. For example, Scrum doesn't recognize roles at all. There's a product owner, there's a Scrum Master, and there's the team. And there's a lot of emphasis on whole team analysis. Craig Larman in particular writes about this quite a lot in Practices for Scaling Lean and Agile, where he says that kind of product owners should only be responsible for prioritization, not for analysis. And a lot of organizations give their product owners the full responsibility to be always right, always correct, always on time. And that's just impossible. Kent Beck kind of wrote in his first edition of XP, explained about XP Customer, that it was this magical role that's always correct, always on time, has all the tests in their head, knows everything that the team needs to do, knows all the tests they need to do, and that's basically just other person's problem. Kind of whatever Kent couldn't solve as a programmer, that was all the magical XP Customer. And the problem with that is that's just not realistic. And even if you can find a person who can do all that, that would be too slow. That's why kind of people go into the water scrum fall part, because it's just too slow to come up with these things. So every single team that got value out of this gets developers, testers, product owners around the whiteboard to translate from scope to a spec. In kind of the Scrum jargon, that would be collaborative product backlog refinement or collaborative analysis. But kind of there's no single team where the product owner is responsible for writing these things. And that's why all those complaints about kind of, hey, we couldn't get our business users to write our tests are insane. Why would the business users write tests anyway? So kind of the next big difference between the teams that succeed with this and teams that just waste a lot of time is what kind of output they produce at the end of these collaborative sessions. Teams that tend to waste a lot of time go for very, very detailed, very, very complex test scenarios. Given I click on this button, then I click on that button, and I click on this button, then the CSS class comes up, then I click this button, then the page reloads, then I wait 10 seconds, then the computer explodes, then everybody gets fired. So tests like that are just a horrible waste of time. They're pointless, they're kind of, nobody has any value out of that. The teams that actually get value out of this tend to focus their discussion on coming up with key examples. They tend to illustrate their requirements, illustrate their scope, illustrate the user stories with concrete examples that are there to capture understanding, that are there to facilitate a shared understanding, that are there to facilitate agreement and disagreements with business people. Kind of, they go for something like this where they can show it to a business user and say, look, this is kind of what we agreed on. Is this going in the right direction or not? Do we need to kind of add more stuff here, or is this kind of relatively okay with what you need? And they don't try and document every possible single testing scenario, because that's pointless. And in particular, there's a lot of kind of mistaken opinion online that by using one of these tools, you can completely replace testing, which is stupid. There's lots and lots of different categories of tests that require human eye and human intervention and human knowledge that can never be automated. There's lots and lots of categories of tests that can be automated, but shouldn't necessarily be automated in this way. There's lots of different stuff there. Kind of these kinds of examples are pretty good for capturing business requirements in a cross-functional way that everybody can understand, but they're not there to replace unit tests, component tests, exploratory tests, or kind of lots of other types of tests. And that's kind of another problem that lots of people misunderstand. So these two things are pretty much what everybody who's successful does. There's not a single team that gets value out of this process where they don't use collaborative analysis or they don't capture key examples. Everything that comes after that is kind of optional. And one option is just take a photo like this, and that becomes a contract between developers, testers, product owners. As a developer, I should no longer be allowed to say I am done until all these examples work, because that's what we agreed on. As a tester, I should pretty much know that by the time it comes to me, the developers have already checked these things, so I can focus on other things. And as a kind of product person, I can at least know that, you know, this stuff has to work, so I can focus on other things. So that's kind of an informal contract between the people in the team. Option number two is people actually create a nice little document out of this. So just a photo is enough. If it's a small team, it's a very dynamic team, everybody's on site, everybody knows what you're doing, but kind of when teams are more distributed, when they are separated geographically or separated by time zones, then it's more useful to create a document out of this. And this is where kind of the next step comes in, which is trying to refine a specification document out of this. And one of the biggest problems that I constantly see with teams that completely waste time is they try to create a document straight away. They skip the collaborative session, they open up Excel or they open up a workflow tool and try and create a spec using a computer immediately. And that's a big problem, because if you have Excel open, pretty much you're guaranteed to end up with a table, even if what you're trying to describe doesn't fit into tables at all. If you have a Word document open, you're pretty much guaranteed to end up with some kind of bullet point outlined list, even though a table might be better, just because it's difficult to work with tables in Word. And things like that. So kind of using whiteboards, using flip charts, using lo-fi equipment is absolutely necessary to get good examples out. And even worse, if you have people who start typing immediately, that means that the whole group is going to work at the speed of that person typing. And that person is always going to play with italics, bolds, tabs, and things like that, and just waste a lot of time. So kind of what I'm trying to say is there's a big difference between people that just waste a lot of time in terms of they're trying to create a fitness page, a cucumber file, a Concordium page immediately by skipping the whole conversation part. And if you are in that position, the best thing to do is kind of get the whiteboard out, get the flip chart out, work with people on getting something sensible on the whiteboard, then refine the document later. So kind of those documents typically tend to look like this. And there might be a summary of a business rule on top, and there's kind of some examples that the team has concluded on at the bottom. And I like to call these things specifications with examples. People like to call them fitness pages, cucumber files, BDD scenarios, and things like that. I like the name spec with examples because kind of it tells you what's in the document. There's a spec on top that's a summary of the business rule, and there's some concrete, clear examples at the bottom that we can use as testing scenarios. And kind of, there's a couple of options after this. So option number one is kind of, we have this nice document, we can send it to external stakeholders, we can say, look, is this what you want to do? And a really great case study for this is a company called Nationwide Insurance. They're a US insurance company, they have stakeholders in all 50 US states. And what used to happen to them all the time is they would get a requirement from one of their customers, say California, and they would implement a change in their insurance documentation. As soon as it goes live, somebody from Texas would complain that they've broken it for their regulation. So then they go and fix it for Texas, but they break it for somebody else. Then kind of they go and fix that, and it took them 5 or 6 turns to actually get things right. After they started doing this, they started capturing their specs in kind of this kind of format. What they would do is about a week or 2 weeks before the iteration starts, they would talk to the original customer that wanted something. They would refine their requirements into an example. They would send it to everybody else and say, look, this is what we're planning to do next 2 weeks. If you want to complain, complain now. And this is where they realized something really, really important. There's kind of a psychological effect that I first heard from Michael Bolton, but I don't know how to explain it. I've certainly seen it with a lot of my customers where people can't really tell you what they want, but they can easily tell you that you are wrong. It's much easier to complain than to kind of give good requirements. So by moving to a process like this where there was something concrete enough to complain, these teams are using examples to actually facilitate disagreement. A lot of writing online is about how, oh, this test, everybody needs to agree on that, but the really good teams use examples to facilitate disagreement and to give people something that's concrete enough to complain about and to complain about early, so that we don't have to blow these things up in iteration demos or, God forbid, when it goes live, we get something that's concrete enough for people to complain early. So another option kind of after this is to start automating some tests based on this. And this is where a lot of people start getting things completely wrong, because something that looks nice and pretty like this gets automated as, given I click on this, when I click on that, then I click on this, and I click on that, and things like that. And you all of a sudden start seeing underscores, curly braces, XML files, and things like that in the test. And that's kind of a wasted opportunity for many teams, because this is something that's nice and clean. Stakeholders can comment on that. And if we can automate it in a way that doesn't break this kind of clean way of reading, we can get a lot more value out of it. And there's a whole class of tools. This is where we come to tools. There's a whole class of tools that can help people automate documents like this without changing them. That class of tools helps people create a single source of truth, where there's no longer a separate document that's a spec and a separate document that's a test. There's one document, and when you update that one document, you have updated the spec and the test at the same time. There's no more kind of, oh, we're going to kind of change requirements now, but 2 weeks later, after we finish development, we don't have time to update the tests. Go and get somebody to test it manually, and we'll fix up the tests 3 months from now, and that never happens. Because there's only one source of truth. And this can be incredibly powerful. So there's a whole class of tools that kind of help automate these things without changing. And that's another big difference between the teams that got a lot of value out of this process and teams that waste time. Teams that get a lot of value tend to keep their automation top-level layer pretty much human-readable as it was on the whiteboard. Teams that waste a lot of time introduce a lot of technical concepts, a lot of automation concepts there that kind of make things easy to automate, but make it almost impossible to show to a product owner later. So one really interesting use for this is that we can show test failures to business people and discuss with them whether this is a bug or misunderstood requirement or something that's entirely expected because we changed something over there and now something over there has changed, and maybe that's perfectly fine. So the previous document that I showed you, if you've never seen one of these tools before, this would be the equivalent of that in fitness when a test fails. Fitness is one of those tools. It's not the only or the best, but kind of when a test fails, it will kind of present pretty much in red what failed. It would say you expected stand, you got a hit, and the document would look pretty much like on a whiteboard. And this is incredibly powerful because we can start discussing stuff like this with business users. There's a whole class of problems where I, as a developer or a tester, am not really allowed to decide whether this is a bug or not, because it's a business model problem. And kind of one really nice example of that is we worked with a financial hedge fund in London where we were migrating from a legacy system. There was a horrible PL SQL piece of crap, and nobody really knew what the old system did. In order to migrate to a new platform, what we did is we would reverse engineer the old code. We would then capture the examples the way we think the system works. We would automate it against the old system, and when the test goes green, we at least know this is what the system does. Then after that, we would go and show people something like this and say, look, just kind of look at this briefly and tell us, does this look kind of okay? And we were using this factor where people can't tell you what they want, but they can easily complain and tell you that you're wrong. Most of the time, everything was okay, but we had one case where one of the really senior people there started shouting at us because we are inventing stuff, and there's no possible way for kind of that report to work like that. And it turns out that there was a regulatory change 2 years ago, and people forgot about that particular report, so it was never changed in the old system. And when we showed him how the report actually works, he said, no, you're inventing things that doesn't work like that. And because we had a test button on it, we could push a test button, it goes green, and we could say, look, this is what the old system does. Now, we can still do it like that, or we can change it, but tell us how you want to change it. And we're able to engage this person in a really productive discussion, rather than kind of the typical, oh, you don't know how the system works thing. So kind of tools like this are mostly useful to engage business users in a discussion about failures. They're mostly useful to kind of provide visibility of what's being tested somewhere else. Kind of so as a tester, I don't have to repeat those tests. And everybody who complains online that they could never get their business users to write these things is getting it completely wrong. The whole purpose of this is so we can show it to a business user when it fails, if we cannot decide if it's a bug or a feature. Stuff that I can decide as a developer or a tester if it's a bug, I don't need to talk to anybody, I don't need this at all. But kind of there's a whole class of problems in most businesses where it's not my responsibility to say if 120 is the right price for this or not. So kind of the really interesting thing that opens up as an opportunity when we have executable specifications is that it's relatively easy to say if this thing is correct or not. If the test is green, it's correct. If the test is not green, there's a difference between the spec and the system. Maybe the system is right, maybe the spec is right. But there's a difference. And generally, when you see that difference, and if it's nice and human readable like this, then you can discuss it with people, you can kind of fix it, either in the system or in the test. And this is one of the kind of biggest opportunities of these tools. I worked with an insurance company in London where they had 7,000 QTP tests, out of which 6,000 were failing all the time. Nobody knew why, and the whole game of development was to just make them fail the same as before. If they started failing in a different way, that's a problem. So when you have something like that, it's impossible to succeed. Where if you have something that business people can comment on, then it's relatively easy to fix up those things. And that's where the real magic comes in. I don't know how many times I've joined a software project where people give me a batch of papers this thick and say, this is our documentation, but it's not entirely correct. And nobody knows what's incorrect. Nobody knows, how far it is from the system. They just know that statistically, there's stuff there that doesn't make sense anymore because it was written a year ago, and we all know that the world has moved on. And the problem with documentation like that is it's impossible to quickly figure out which pages are incorrect. If our specs are in this format, it's trivially easy to figure out which pages are incorrect. Is the test green or red? If it's green, it's correct. If the test is red, then there's a difference between the test and the test or the spec and the system. So we need to figure out which one is right. Now, this is another reason why kind of it's so important to capture key examples rather than capturing kind of 5 million left-hand menu item clicks. Once we have something that's nice and clean, relatively short, relatively easy to understand, if we figure out that it's wrong, it's relatively easy to fix. Which means that if we run these things frequently, we can fix them up over time, and we can keep the distance between the spec and the system relatively small. We can have something that explains how the system works. We can have something that continuously explains what's already automated and already tested, and we can trust it. We can get documentation we can trust. So another big difference between lots of teams that succeeded with this and teams that kind of failed completely is that generally people tend to validate these things frequently so they can keep the distance between the test and the system short, and they evolve a documentation system out of this. It's not just a set of tests. It's a documentation system that explains how the system works. It's something that business users can look at. It's something that business analysts can look at if they want to talk to a customer and know how the system works. It's something that testers can look at to figure out, well, how should we test this part of the system, and what are the dimensions, what are the variables there, and that can inspire testers to do more exploratory testing. It's something that provides clarity to everybody, where kind of people that just waste a lot of time tend to create these things that are associated with user stories, and then there's 13 million of these. They're organized in a way that nobody understands. They're all in a single folder, and hopefully they're in some shared server and not on somebody's laptop that nobody knows about. So kind of people that got a lot of value out of this actually evolved the documentation system out of it. By far, the furthest thing I've heard anybody do with this is Rick Magridge's presentation, Doubling the Value of Automated Tests. You can Google for that title, and there's a video of him presenting at, I think, the Google Test Automation Conference in 2010, where he talks about that one of his clients, that was an airline, actually cleaned up their automated specs and tests so much that the call center people were using that as a reference for pricing models and for kind of business workflows when they can refund the ticket when they can't. So that's kind of a very, very kind of edge case scenario. Most of my customers don't push it that far, but they get a documentation system that analysts, testers, and developers can use without anybody having to reverse engineer the code all the time. And that's where we can get another benefit out of this, where we can prevent our systems from becoming legacy. People start rewriting legacy stuff when it's too difficult to maintain, too difficult to understand, and no longer anybody knows anything about that. Where with kind of documentation like this, we can provide a fantastic level of visibility to everybody, so we don't have to rewrite these systems all the time. So kind of this kind of thing then informs the cycle further, and when analysts need to figure out what to do next, they don't have to wait for a developer to reverse engineer something. They can just look at the document and take it to a customer and say, this is what the system does now, how do you want to change it? This is what testers can use to figure out what else they need to do and how else they need to plan their tests. Or if they're working on a similar part of a system, what tests have we done over there? So kind of that's a really great way of capturing knowledge. So that opens up some really, really interesting possibilities, where kind of a lot of teams I work with these days have kind of many, many more developers than testers and analysts. And they're typically kind of organized in a way where one or two product people are doing requirements, they're pushing work to kind of 10, 15 developers, and these push work to one or two unfortunate testers who need to kind of catch up with everything and suffer by testing over the weekend and things like that. And generally kind of there's been an insane amount of advancement in the industry over the last 10 years in this area over here. We have much, much better tools for development, much better tools, much better process for development and things like that. And a lot of organizations are just not getting the benefit out of that because they're not moving at the speed of developers. They're moving at the speed of how many requirements these people can produce, because developers can develop a lot more. And typically when they get half-baked stuff, it just comes back and comes back and comes back. So we're moving at the speed of these people, or they move at the speed of kind of these two unfortunate people over there, because if developers can produce more software than can be tested, then it's just going to come out and come back immediately. So there's a couple of opportunities that kind of this kind of process opens up, and in particular, collaborative analysis, where testers, developers, and analysts together come, and then testers complain, developers complain, everybody tries to complain, and they get examples out. allows testers to significantly change their role. So testers no longer have to be responsible for quality assurance, and in most teams that got value out of this process, testers are no longer responsible for quality assurance. Testers are responsible for teaching developers what to test and contributing examples at the start, and then doing stuff that really, really requires specific testing knowledge, like difficult exploratory testing and things like that. So testers can get time to do stuff they never had time to do before, because developers are responsible for doing most of the grunt work. And the guys at Atlassian have a really nice name for this. I've heard it from Sige, and he calls this quality assistance rather than quality assurance, where the tester's responsibility is mostly to contribute what kind of test cases they'd like executed, and then it's somebody else's responsibility to execute this stuff. And this makes a lot of sense from just the distribution of work, because there's 15 people over there, there's 2 people over there. And the kind of context-driven testing community makes a big distinction between checking and testing. They say that checking is something that kind of has a predefined input, a predefined output, and then kind of somebody needs to compare the system to that and check it. That's a class of useful tests, but kind of what they call testing is completely different. It's something that requires human observation, something that requires human knowledge, inspection, and things like that. It's kind of looking for unexpected stuff. And if we divide it like this, then kind of the magic with checking is, can we come up with good checks? If we can come up with good checks, then does it matter who executes them? A tester can, a developer can, a machine can. Pretty much it doesn't matter. So kind of in that kind of terminology, the quality assistance idea is that testers are responsible for contributing to the set of checks, but then developers go and execute the checks, and testers can get a lot more time to do real testing, where all of a sudden there's no longer a bottleneck there on testing, so the kind of fall part of water scrum fall is removed. Now, the other interesting perspective of this is kind of, if teams move at the speed of how many requirements one product person can produce, and we replace that by collaborative analysis, we replace that by not just one person writing down these things and them exploding, but 20 people looking at it and collaborating on that, then we can do that a lot faster as well. So kind of all of the teams that got a lot of value out of this change the process so that kind of product owners are responsible for prioritization, but not for analysis, not for requirements, not for documentation. Product owners are responsible for facilitating the collaboration on this. And it's the responsibility of the whole team to do that. And Craig Larman has a couple of really nice case studies about this in his book on practices for scaling lean and agile. And even kind of Kent Beck, who in the first edition of XP Explained wrote that the XP customer is responsible for this. In the second edition of XP Explained, writes about the whole team being responsible for these things. Just because it's a lot faster, and by the way, if testers and developers participate in defining requirements, they don't have to read stupid documents anymore that nobody wants to read. So kind of this opens up some very, very interesting possibilities for kind of getting the whole pipeline to move at the speed of these people rather than these people or those people. And an individual developer is kind of slowed down a bit in this process, but the whole pipeline moves a lot faster. And lots of people I spoke with, lots of people I worked with, as a result of changing the process like this, started delivering 5 to 10 times faster. Their cycle times dropped by 10 times. Just because they've removed the bottlenecks and now kind of the pipeline moves at the speed of developers. And this is where kind of we can't just think about these tools as test automation tools, and we can't think about Spec by Example or BDD as a test automation approach. The value is in changing the process. The value is not in kind of automating tests in a different way. Automating tests in a different way is just a nice side effect of that. So kind of to finish things off, I just like to give you a couple of quotes from people that got a lot of success with this. Rather than kind of random complaints about tools online, you can see kind of what people got out of this. So USwitch is one of the most popular websites in the UK, and they started changing the process. I spoke to them kind of about 4 or 5 years ago. At this point, they were completing a large process change. that was caused by pretty much them deciding that the delivery phases are too long. They were about 6 months then, and they had so many problems in production that I think either the CIO or somebody like that was kind of replaced to bring in somebody else. And after about 6 months of process changes, they reduced their delivery cycle from 6 months to about 3 weeks. And they were able to kind of improve the quality so much that one of the developers I spoke with there says that kind of the error rates have dropped significantly across the site globally, and the turnaround for fixing problems when they occur dropped from several days or even several weeks to several hours. This is because people had much better visibility what else is in the system. If I'm a developer and I need to fix a problem, I don't have to go and talk to 20 other developers to see how I'm impacting their components. I can see that stuff. If I'm a tester and need to test something, I know what developers have already tested, so. And there's a lot of stuff that was automated in a different way as a result of this. So the other team I spoke with was Sabre Airline Solutions. Those are people who produce one of the 2 most popular airline reservation systems in the world. Very, very complex, very distributed, not, your very, very simple website that can crash if 5 people come there. And Wes Williams, who was one of the leaders in this project, told me that they were trying to replace a massive legacy, and they pretty much failed doing it once because of all the domain complexity. The second time when they restarted, they were using this process straight from the start to capture requirements, communicate across teams, across different time zones, across different locations. And the previous attempt to rewrite this, when it went to user acceptance testing, the customer canceled the contract. This attempt, same people, a different approach. When it went to testing, when we went to business acceptance testing, there was only one critical problem they found, and that was related to hardware, not software. So that's a big difference. That's a massive difference that people have done in their process. The third theme that I spoke with is a team called Sierra at BNP Paribas. Again, a global bank, a large organization, not somebody that does small websites. And I spoke with them in 2010 or 2011. They were working on a mission-critical project for the bank that was consolidating bond data information from lots of different sources, producing a golden data source, pushing it out to all the other parts of the bank. So something that's really, really critical for the whole thing. And because they were using this process and a lot of other things, this is not the only thing they were doing, but they were able to create a level of quality where they have not recorded major incidents in production for 5 years. So the next team that I spoke with is an insurance company in the UK that's called Beazley, and Beazley had a typical water scrum fall problem. Their testers were working on a completely different cycles. Developers would finish testing, then developers would finish development, testers would have to start testing. They were working on a completely parallel cycle because it was slow, and stuff was coming back all the time. There was a ton of rework the developers had to do because of slow feedback. By changing the process to collaborative requirements, getting testers involved up front, changing how they approach this whole thing, they were able to move most of the responsibility for checking to developers, which then meant that testers were free to do other stuff, so they could improve quality by exploratory testing, by doing other things. That also meant that by the time a developer says, I am done, it's done. It's not, I am done, but somebody needs to do 2 weeks of testing, and because that person is busy, it's going to wait for a week as well. By this point, they were able to integrate testing and development pretty much in the same cycle. So, another team that I spoke with is Weyerhaeuser. This is a huge construction company in the US, and they had this problem where they were building a library for creating blueprints for how to cut wooden frames for a house. And you'd put some parameters in, out comes a plan for the house, and they had so many problems that they fired their head of testing because, of course, he introduced the problems in the first place. That's where problems start. And they hired this guy called Pierre Verhagen, who started changing the process, and about 15 months later, they've cleaned up the stuff so much that they stopped using a bug tracking tool. Now, this was a product that a year and a half ago, the head of testing was fired because of problems. A year and a half later, they stopped using a bug tracking tool. That's how much they cleaned it up. And their engineers, their kind of product owners love the whole approach because they can kind of contribute, they could participate in examples, they could see what's going on, they could have the visibility. So kind of, instead of trying to get the engineers to write tests, which is kind of pretty much a stupid idea that everybody would complain about, they got these people engaged to try and figure out what quality means and provide enough visibility and observability there so that they can control it nicely. So the next team that I spoke with is Iowa Student Loan, and Tim Anderson, who ran a project there, ran a large business change project in 2007 where, because of the credit crunch, their business model no longer worked. Which is really interesting because kind of as a technology-driven business, because their business process was so hard-coded in the technology, when the business model changes, if they can adapt the technology, that means they can change the business model quickly. And most of their competitors at this point went bankrupt because they could not adapt that quickly. These guys were able not just to survive, but kind of do quite well that year. And they did it because their key business people were able to look at their business processes in a good documentation system that they knew they could trust, and then figure out what are the minimal changes that they could do for regulatory approval, for this thing, for that thing, and define a relatively small change that they could do on the system. So although that was a small change, it was changing a crucial piece of their reporting infrastructure because they were moving from a single large investor to lots of small investors, and there were a lot of requirements for isolation. Tim, who was the technical lead there, said that if they didn't have the living documentation produced, the result of kind of building this stuff up over the years, he would have been more comfortable with the rewrite. Because this was a critical component, they didn't know what, you know, whether they can change it safely or not, but because they had living documentation on this, pretty much everybody changed it very, very quickly with a high level of confidence. So at the time when most of their competitors went bankrupt, these guys were able to kind of shut down the business for 2 months, re-engineer a critical part of their kind of technical components, and then go live again. And kind of that's the real benefit of this. The real benefit of these approaches is far, far beyond testing or far beyond test automation. And when people just want to do test automation, that's what you get. You get tests automated in a different way. None of these benefits are there, and then it becomes too expensive, too slow, and things like that. But this brings me then to kind of the final thing. If we are going to get people motivated to change, we need to stop talking about test automation. We need to stop talking about automation tools. The nice side effect of this. What we need to start talking about is kind of what are the top 2 things people need to remember to get started on the right path. And I think kind of from all of these case studies, the kind of top 2 things I think about kind of spec by example or BDD are specify collaboratively and focus on key examples. Everything else is going to flow from there. Because when we get teams to collaborate on specifications, we can start rearranging the process. We can start moving away from quality assurance to quality assistance. We can start moving away from product owners being responsible for requirements to product owners being responsible for collaboration, which means that the pipeline starts moving 10 times faster. And when we focus on key examples, we can create stuff that's not perfect, not 100% of testing, and not going to replace testing, but something that facilitates shared understanding enough so people can work faster. So then other types of testing can be done, and other things can be done differently. So that's pretty much it. Thank you very much for kind of listening on this, and I hope I've motivated you to change the process at least slightly. As a small gift for kind of spending 1 hour of your life with me, I'd like to kind of give you my latest book for free. And the book is called 50 Quick Ideas to Improve Your User Stories. If you go to this URL over the next month, you can download the book for free. That's pretty much it. Thank you very much.
In Polish we say that the devil is in the details.
Okay.
Many problems are in the details. If we concentrate only on key examples, what was the details? That's my first question. The second my question is that from my experience, typically you are right in one of your examples that say developers, not engineers, whatever we call them, it's not a problem. They like to write tests, but they concentrate on something which will be called positive tests. What happens if I introduce a correct data and I obtain the correct result? They skip the situation when the user introduced by mistake.
Yep, that's...
You understand the question?
Yeah, so, okay, so the first question is about key examples and details. And lots of people misunderstand key examples as a loss of details. Key examples are everything but that. Key examples are finding a good level of abstraction to capture the important details, but only the important details. So, there's a whole kind of way of getting to those things, but in my experience, or what I want to say with key examples is capture the really difficult stuff. So that's why I said one of the biggest differences between people that waste time and people that succeed is people that succeed capture the really difficult stuff in a way that is relatively easy to understand. That's what I call a key example. Albert Einstein said that if you can't describe something simply, you don't understand it well enough. So the fact that something is complicated does not mean that it can't be described well. And key examples are all those kind of really, really difficult things that people need to understand. The other question you asked about developers writing tests, that pretty much goes against everything I said. I said collaboration. So developers, testers, and analysts together decide what's important. And you're absolutely right. Developers tend to focus on the positive stuff, but that's why there's collaboration up front, where collaboration is kind of on two sides. Testers are responsible for saying, oh, what about this, what about that, what about that? And there's two classes of things there. One class of things there is unexpected problems. As a tester, I have domain experience in this. I've seen users doing stuff. I know that where developers make mistakes, I expect those problems. Those are deterministic checks I can define. There's a whole class of problems that's kind of unexpected stuff that this thing is not touching at all. This thing is just giving you more time to do the unexpected stuff by taking the burden of checking the expected stuff and putting it somewhere else. So testers get a lot more time to do unexpected style testing. So that's my experience with the teams like this. So there's a lot of, kind of spec by example is deceivingly simple. What I mean by that is I can explain it like this, but it's very difficult to pull off. And coming up with good key examples is one of the most difficult things there. Teams that can focus on good key examples, where key examples capture the intricacies of the domain, the complexities of the domain, they get a lot of value out of this. So that's what I wanted to say when I said key examples. I didn't want to say kind of only the happy path and something that's stupid, but kind of key, critical, crucial.
Could you give some example how this collaborative story writing should work? Because in my team, it usually looks like that we have backlog refinement. We see something, we collaboratively decide if it's ready for work or not. And if it's not ready for work, somebody says, okay, who wants to make this ready, so write this. And I'm thinking it would be difficult to convince my team to say we should spend the time and the resources of a whole team on each and every single user story. So could you, I don't know, give some examples, some data that could convince them, I say this to them, convince them for this?
So first of all, this does not apply to all possible teams. It's not a silver bullet. It might not even work for you. Maybe it doesn't apply. So this process tends to apply with complex organizations or complex business domains. The examples I gave you where people got a lot of value, banks, insurance companies, large distributed organizations, complex domains, people where developers and testers are not domain experts, where the complexity of the organization or the number of stakeholders makes understanding the requirements difficult. Stuff where the critical complexity is technical, where you don't need to talk to 50 different people, you don't need to analyze third parties, there's no distributed organization where a single team is relatively small, everybody knows what they're doing, this thing just complete overkill. So assuming the other situation, assuming that this thing actually applies, kind of generally, because it's difficult to understand the domain, things come back quite a lot. And because things come back quite a lot, developers have to do rework. Developers have to fix, developers have to talk to other developers, context switch. Because things are difficult to understand, testers don't know if they have the complete picture or not. So problems go to production. Then they come back. So in a case like that, the convincing factor is, well, you know, what if you could solve those problems? In a case where you don't have that, you have either solved this problem somehow differently, or you don't have the problem, so this thing wouldn't apply. So, by the way, kind of as a tip for organizational change, it's related to this but not specific to this, there's a fantastic book I stole a lot of ideas from, and I use it all the time with clients. It's called Switch. And Switch is a book how to cause organizational change where you don't have any political or financial influence. So if you want to kind of get your team to change, there's lots of good ideas in Switch that can help you kind of come up with ideas how to change.
So if I can refer to a question, what about just free amigos meetings? You don't need a whole team to build up a collaboration. Probably, in this case, you have a big team. You can just probably collaborate, like get one QA, one product, and one developer. What do you think about it? Is it okay? Is it for collaboration for you, or you need more?
So I think the critical thing here, and that's why I said collaborate, is you get different roles to kind of contribute to the spec. You get testers to contribute to all those things they know are going to fail to the spec, developers to find functional gaps. So Three Amigos is a perfectly valid way of collaborating. Whole team workshop is a valid way of collaborating. They apply to different scenarios. Whole team workshop typically applies to scenarios where everybody's co-located and testers and developers are not domain experts, because then a single domain person can teach 20 other people about the domain. Where Three Amigos works really, really well if testers and developers know enough about the domain so they don't need to learn about the domain. So, and kind of they also work a lot better for distributed teams because you can do a Three Amigos screen share where if you join to a 20-person screen share, 19 of them will play Angry Birds while one is speaking. So, yeah, that's a perfectly valid way of collaborating. So it's important to get, in order to be able to switch from kind of quality assurance to quality assistance and from one person responsible for requirements to collaboration, you need to get more people involved. And depending on the context of the team, there's different ways of collaborating. So that's a perfectly valid way of doing that.
I have a question about the company that was using it as for the support, where support were using the cases from the making BDD. How was that done? Because in the past I was using SpecFlow and I had a very big problem with just sharing the cases with the support because everything was in SVN and they didn't have access to that. How the company there was
kind of the customer support case I mentioned is kind of the edge case that Rick Magrish talked about. I've not worked on that project. There's a video called Doubling the Value of Automated Tests. You can look at that. They were using Fitness because Rick Magrish is a big Fitness contributor. So Fitness is a website already. With SpecFlow, there's a couple of really good options. One is Relish, the other is Cucumber Pro that will take SpecFlow files and produce a nice website. So it's a read-only website that you can publish as the last step of your build process. And then you can kind of, that can be a website people access. It's going to create a table of contents, an index on the left. There's a tool by BBC called Wally that's doing a similar thing. And there's a tool by Jeffrey Cameron called Pickles. I don't get the whole vegetable metaphor there, but Pickles is a exe program that's going to take your SpecFlow files and create a website out of that as well. So those are some potential options. So those are the three main options there. Relish is a hosted solution. The guys behind Cucumber, actually there's a fourth one there. So the guys behind Cucumber are working on Cucumber.pro. They're working on Cucumber Pro that's going to integrate Relish as well, or provide the replacement for Relish. So those are kind of the four main options to do that.
The examples that you've passed are really interesting. I'd like to know what kind of, or how they push the new process into the companies that you talk to. So if you have some examples of how to push the new process, it would be really interesting if you talk to them.
So there's several ways of how to push the new process out, and kind of that's really context specific. We'll stay here until tomorrow morning for that. But one example that I can give you is where, that's kind of the Weyerhaeuser example. They started using the theory of constraints as their guideline. So the theory of constraints says that in any kind of process, there's one part that's the slowest, and if you want to improve the process, everybody has to work on that part. So what they did is they were trying to kind of all the way end to end figure out what part of the process is causing most problems at the moment, and then developers, testers, analysts, everybody had to help improve that part of the process. So say, you know, when the problem is the testing is very slow, then developers had to contribute to testing, and they started automating data preparation, data cleanup, and things like that, and then gradually they got to tests like this. And then the bottleneck moved. Then developers were the slowest part because of context switching, so then developers got the responsibility to execute tests themselves rather than testers executing tests later and things like that. So that's a nice way of kind of looking at where's your biggest bottleneck at the moment, and then can any of these ideas help at that particular point? Because if not, then this is not a good solution then. And if any of these ideas can help with that, then kind of you can try it out. So that's kind of, that's one example. But there's several other detailed adoption scenarios in the specification by example book. Thank you.